All right, so working with vectors in a plane is easier when we're working in the coordinate system. When the initial points and the terminal points of vectors are given in Cartesian coordinates, the computations become pretty straightforward. So let's figure out if these vectors are equivalent. So now we're working through example 2.3, comparing vectors. So are V and W equivalent? All right, so for part A, V has initial point 3, 2, and terminal point 7, 2, whereas W has initial point 1, -4, -4, on my folder, just do that, and terminal point 1, 0. So I'm going to start just by sketching this up, right? Because it's the only thing that we really know how so far. So these are, well, we do have this negative y value here, so this goes up to 7. Let's see. All right. Fantastic. We get like 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So I'll sketch them all in different colors. So I'll use orange for V. We have an initial point of 3, 2. All right, this is pretty straightforward. Terminal point of 7, 2. Okay, so what we have here then is a vector that's going completely horizontal, and it's got like a length that looks like it's like 4. All right, and then W on the other hand is going to have initial point 1, -4. I'll draw that one in pink. 1, -4, and terminal point of 1, 0. All right, so this one is completely vertical. It also has a length of 4, but the direction is completely different. So because the directions are completely different, because that's what we need, right? Vectors are going to be the same if they have the same direction and the same magnitude. All right, now let's take a look at B. So for part B, we're starting at the origin. So B has initial point 0, 0. And terminal point 1, 1. While W has initial point -2, 2, and terminal point -1, 3. So let's see. I'll sketch this in purple. So we're starting at 0, and we're going up to 1, 1. So that's not too bad. All right, we're going up 1 over 1. That's fine. And then W, whoops, we're actually starting at -2. So I'm going to go ahead and work in these negative values on my x-axis. All right, so W I'll do in green. Has initial point -2, 2, and terminal point -1, 3. So we've done the same thing, right? We've gone up 1 and over 1. That means they're going to have the same direction and the same magnitude. So in this case, the vectors are the same. So because V and W have the same magnitude, and direction. The vector v is equal to the vector w, so it doesn't matter that they're actually starting at different places. Let's just check our answer with these solutions here. Okay. So yeah, it says the vectors are each 4 units long, but they're in different directions, so they are not equivalent. Okay. And here, it's clear that they do have the same length and direction, so they are equivalent. So we get it. All right.